All right, 4, 5, and 6, we're going to do the ANOVA test, degree of freedom, and F statistic. We're going to have both a degree of freedom in the numerator and the degree of freedom in the denominator. So my degree of freedom in my numerator, DFN, will be how many groups minus 1. I'll write it that way. How many groups minus 1? In this case, how many groups do I have? I have 1, 2, 3, 4 groups. So my DFN number is going to be 4 minus 1, which is just going to be 3. How many groups? Here's my groups. I have 4 of them. My DFD number, degree of freedom in the denominator, is going to be the sample size total minus my how many groups. So my sample size total would be either I could add all those numbers up. If I added all those, however, it should come up to the same number, in this case, of how many people they questioned. So if they have that in the word problem on how many respondents they have, I probably don't need to add those, but just to double check myself, I could add those, take my 256 plus my 269 plus my 256 plus my 292, and it should come up to the 1,073. So I'm going to take my 1,073, and then I'm going to subtract how many groups. We had 4 groups. So 173 minus 4 would give me 1,069. We're going to need those when we do our F test. So on here, it says, the General Social Survey is an annual survey given to a random selection of about 1,500 adults in the United States. Among the many questions asked are, what is the highest level of education you've completed? And if you're employed full-time, how many hours do you spend working at your job during a typical week? In a recent year, 1,073 respondents answered both questions. The summary statistics are given in the chart below. The sample data consists of the times in hours per week that were given by the respondents. So if I had less than a high school education, my sample mean was 42.6, my sample variance 110.1, and so forth. To decide if there are any differences in the mean hours per week worked by these different groups, we can perform a one-way independent sample ANOVA test. Such a test uses the test statistic F, the variation between the samples and the variation within the samples. Now that's what we calculated on problems 1, 2, and 3. They're not going to make you figure out those numbers. They're going to tell you this is my value for F. So we're going to find the p-value that corresponds to that. So on the ALEKS calculator, we are going to do P of F is greater than. P of F is greater than our 1.57. Degree of freedom in my numerator, we figured out earlier, was 3. Degree of freedom in my denominator, we figured out earlier, was 1,069. So in the ALEKS calculator, you are going to do P of F is greater than. We're doing the F test. They'll have the number given, already calculated out for you. The degree of freedom in the numerator was how many groups minus 1. The degree of freedom in the denominator, the total sample size, which either is going to be in the word problem or you have to add up your total sample size, minus how many groups, which again is the 4. So if you calculate that out, and it says round to 3 decimal places here, you should get 0.195. That's the percentage, 19.5%. It says From the survey data, can we conclude that at least one of the groups differs significantly from the others in mean hours worked in a typical week? Use the 0.5 level of significance. So, again, when we're comparing our p-value, 0.195, if we get a greater, we're going to accept the null. If it's less, we reject the null. In this case, if I'm going to do the null is that they equal. The alternative one is that they are not equal. So, looking at this, 0.195 compared to 0.05 level of significance. 0.195 is greater. So it says here, if it's greater, we're going to accept the null. The null says that they're going to be equal to each other. The question says, can we conclude that they differ? Well, if they're equal, they're not going to differ. So, no, we can't say that they differ. We would have to conclude that they're equal. So my null again is equal. My alternative one is they're not equal or they differ. Number 5 then. Chris Turlock owns and manages a small business in San Francisco, California. The business provides breakfast and brunch food via carts parked along the sidewalks to people in the business district of the city. Being an experienced business person, Chris provides incentives for the 4 salespeople operating the food carts. This year, she plans to offer monetary bonuses to her salespeople based on their individual mean daily sales. Below is a chart giving a summary of the information that Chris has to work with. In the chart, a sample is collected of daily sales figures in dollars from the past year for a particular salesperson. Salesperson 1, their sample size was 76, their sample mean 205.1, their sample variance 2,593.9, and so forth. Chris's first step is to decide if there are any significant differences in the mean daily sales of her salespeople. There are no significant differences. She'll split the bonuses equally among the 4 of them. To make this decision, Chris will do a one-way independent sample ANOVA test of equality of the population means, which uses the test statistic F. The variance between the samples, the variance within the samples. They've already done all the math and the calculating, and they're going to give you the variance or the value of F. But we need to find the degree of freedom in the numerator and then the degree of freedom in the denominator. So my degree of freedom in my numerator again, the number of groups minus 1. We have 4 groups, so 4 minus 1 is going to be 3. The degree of freedom in the denominator, the total of the sample size minus the number of groups. In this case, they didn't give you the total of the sample size anywhere in the word problem, so what we have to do is find the total ourselves. 76 plus 84 plus 50 plus 99. So if you add up all of the totals for your sample size, 76 plus 84 plus 50 plus 99, you should come up with 309 for your total of all of your samples. So I'm going to take the 309, I'm going to subtract the number of groups. Again, we had 4 groups, so 309 minus 4 would be 305. So then I can calculate my test statistic, and in case this one here, they divided it up. Give the numerator degree of freedom. Well, we figured that out already. It was 3. Give the denominator degree of freedom, 305. And then it tells me, can we conclude? But if I have to conclude that, I first have to find my p-value. It didn't ask for my p-value separately, so I got to calculate my p-value. I'm going to do P of F is greater than 2.14 with a degree of freedom in my numerator of 3 and a degree of freedom in my denominator of 305. And I'm going to punch that into the Alex calculator and figure out what I get for my number. So if I figure that out, P of F is greater than 2.14, degree of freedom of 3, and in the numerator and the degree of freedom in the denominator of 305, you should come up with 0.095. So now we can use that to determine if that works with our level of significance. So if I have 0.095 and I'm comparing it to 0.01, 0.095 is greater than 0.01. That means we have to accept the null, and the null says that they're equal. We're going to accept that they're equal. So it says, can we conclude using the 0.01 level of significance that at least one of the salespeople is significantly different? We have to accept that they're all equal. That means we can't say they're different. So number 6, Joint Soft is a great over-the-counter arthritis medication. But who will ever know about it? Unfortunately, many people with arthritis tend to be elderly and rather immobile, so advertisers of arthritis medications face limitations in ways to get their messages across. Currently, their best modes of advertisement are commercials on daytime TV, advertisements in select magazines, flyers in convalescent homes, and believe it or not, advertisements on certain web pages. Marketing managers for Joint Soft are investigating these 4 modes of advertisements in 4 small communities with a different mode of advertisement in each community. The marketing managers have selected 35 days at random and are looking at the daily sales in dollars of each of the communities on each of these days. Here's what they have to work with. So again, they have 4 groups: TV, magazines, flyers, and web pages. Their sample size for each of them are 35, and so forth. It says, suppose that the marketing manager performs a one-way independent sample ANOVA test to decide if there are differences in the mean daily sales arising from the 4 modes of advertisement. So they're assuming that the only differences among the 4 communities is the mode of advertisement used in it, and they're going to use the F statistic. Again, they've already calculated the variation between the sample and the variation within the sample and come up with your value for your F test. So we need to know the degree of freedom in the numerator and the degree of freedom in the denominator. So our degree of freedom in the numerator, again, we took the total number of groups, which was 4. We subtracted 1, so we have 3 degrees of freedom in our numerator. For our degree of freedom in our denominator, we needed our total sample size. Well, since they're all 35, you could take 35 plus 35 plus 35 plus 35, but it'd be way quicker to do 35 times 4, since we have 4 groups of 35. 35 times 4 should give me 140. So for the degree of freedom in my denominator, I'm going to take that 140, and then I'm going to subtract the number of groups, which is 4. 140 minus 4 would give me 136 for my degree of freedom in my denominator. So now I can calculate my P value for my F statistic. We're going to do P of F is greater than 1.71, which is our given value, with a degree of freedom in my numerator of 3, degree of freedom in my denominator of 136. Again, we need to put that in on our Alex calculator. P of F is greater than 1.71 with a degree of freedom of 3 in my numerator and a degree of freedom of 136 in my denominator. Hopefully you've punched that in. My point didn't show up very well. 0.168 should be my value. So using a 10% level of significance, Can the marketing managers conclude that the mean daily sales are rising from at least one of the modes differs from the other? So again, my p-value 0.168 compared to my level of significance 0.10. Again, we got greater. 0.16 is greater than 0.10. If that is true, we have to accept the null. And the null says they're equal. So can we say they differ? No. Again, we have to say that they are equal, they are not different, and so we cannot accept the null. We didn't have any that were less, but if we had one that was less, then we would say that it differed because we would not accept the null.